Alright, welcome to our MATLAB tutorial. We're going to start on a new series called User-Defined Functions. Very similar to a lot of the functions we've learned in this course already, such as the sine function and linspace. User-defined functions allow us as programmers to create a function that can be called and used from the command window, from another script, and so on. Now, there is a difference between a function and a script, even though they're going to look very similar when they're being created, as they both are .m files. One key difference, though, is that a script file inherently uses the workspace that you would see in your command window, whereas a function or a user-defined function has its own workspace. Now, the script file is a collection of MATLAB statements stored in a file. It's lines of code, everything that we want to execute. Plot this, display this, x equals this array, and so on. It shares the workspace that's in the command window. If we define A and B in the command window, we can use A and B in our script file. The key difference here is that there are no input arguments and it returns no results. Of course, unless we ask it to return results. We can use the fprintf function, we can use the display function, and so on. A function is different. It's still a .m file, but what we do is we're going to pass input arguments and get output arguments. Very similar to one of our functions. For example, if we look at the linspace function, we have 2 or 3 inputs. We have a starting value, an ending value, and possibly the number of points between those two values. But what's different is that it has its own independent workspace, which means we can create variables inside of our function that do not communicate with the variables in the command window. It only gets data through an input argument list. Let's look back at our linspace function. We give 3 input variables, sometimes 2 input variables, and that's it. We get an output. That output is an array of some size. Our function works just like that. We have to send our function inputs, and what we get are outputs. We call those the input argument list and the output argument list. We can use this function anywhere, just like we can use the sine function or the ABS function anywhere we want. We can use it in our scripts, we can use it in the command window. We can call our user-defined function from any of these areas as well. So here's what it looks like. Very first line, we're going to start with the word function, spelled out just like that. This is the command that tells MATLAB a function is coming. Immediately after that, we're going to see these square brackets, and then we see output arg1, output arg2, ... These are all of the output arguments that we're expecting our function to return back to us. We can have as little as 0. We can have 1, 2, 3. We can have as many output arguments as we want. And we're going to say those output arguments are equal to fname. Fname is the name of our function. And what's really important is that when we save our function as a .m file, the name of the .m file has to be the same as this fname. After that, the input arguments. What is the information we are going to feed into this function in order for the function to calculate all of the outputs? And then below that we see some comments. The comments are denoted in green. We see the percentage sign. Very first line underneath function says H1 comment line. That means the header comment line. After that, we have other comment lines. And we'll get into exactly what these mean in a minute because they are very important. What follows? Any executable code that we want. All of the calculations that we need, maybe it's plotting, maybe it's creating matrices and arrays, it doesn't matter. What does matter is that the output arguments that we asked for in the first line are listed below and declared. So let's do a quick example and look at these function basics. So we talked about this first comment line called H1. It should contain a 1-line summary of what the function does. Now, if you've ever struggled understanding the purpose of a function, maybe you've used the help command or the look for command. we use those to find out information about a function we want to use. If we don't know how to use the linspace function, we can go into the command window and say look for linspace or help linspace. The only difference between the two is that look for is only going to give you the very first line. That first line is the H1 comment line. When you use help, you get all of the lines of code that are commented right after the function line. Then we talked about the function being executed either in the command window or in another program. And what we do is we type out the argument outputs that we want. In this example, we're saying res1, res2, and so on, is equal to the name of our function and then whatever input arguments are required. Now it says here that it's highly recommended that the function is saved under the same file, but you will find that if you do not save it as the same name, you will have issues running the code. And another note, functions are saved as a .m file. You will not see a difference in your current directory of your function name. It will look just like a .m file. So let's do a quick example. If we imagine that we have a point on a Cartesian plane such as xy, but we want to express it in in polar coordinates, r theta, we have these simple equations here, where x is equal to r cosine theta, y is equal to r sine theta if we want to go one way, or we have the equations for r and theta if we want to go the other way. So what's the pseudocode to perform an activity like this? Well, we state the problem. We want to write a function that converts coordinates from rectangular to polar. We have to understand what our inputs and outputs are. That's especially important in building a function. So our inputs in this example will be x and y. We know a point on a 2D plane. Our outputs are going to be r and theta. So we have inputs, we have outputs. What's the algorithm to get us there? That's the equations that we have in point 3 describing the problem. We have an equation for r, which is the square root of the sum of x squared and y squared. And we have theta. We can use a tan 2 or a tan 2d. It's up to us. Now, so far, we've done it this way. We've asked the user for x and y. We've used the input function. We've calculated the different equations for r and theta. And then, depending on what we are more comfortable with, we can use the fprintf. We could use the display. This gives the answers back to the user. But when we do a user-defined function, the strategy is a little bit different. Notice you see a lot of green here, a lot of comments. Comments are absolutely critical when we're creating a user-defined function. So in the very first line, we say function r theta. R and theta are the outputs that we want. And because we're asking for more than one output, we need to treat those outputs in an array, an argument list wrapped in square brackets. Then we say that the argument list is equal to rect2 polar. Now, rect2 polar is not a known function. It's the name that we're going to give our user-defined function. Then we have xy. Those are our two inputs. That's the information needed for our function to get to an output. So the very first line underneath says rect2 polar converts rectangular to polar coordinates. Very simple, one-line summary. If we were to type this into MATLAB and we said look for rect2 polar, the name of our function, it's going to return to us this first line. All of the other lines of comments are as detailed as we want or as we need them to be. We could talk about all the different variables, what they are, what they look like, and then at the very end we have r and theta. The most important thing with doing something like this is, one, all of our inputs need to be used. MATLAB will not error, but it's going to get confused. It says, well, we're saying that x and y are inputs, but I'm not seeing them used anywhere in the equations. Luckily for us, when we look at r and theta on the bottom, we see that both x and y are utilized in both equations. Second most important thing, our outputs, r and theta, must be declared somewhere in the code. So let's do an example using MATLAB. So in order to start our function, we're going to type the word function. Now, Many of you may be used to putting comments in line 1 about who your group is or what the function does or your name or the date or something. When we do a user-defined function, we always want line 1 to be our function line. Not line 2, not line 3. Line 1 should be our function line. So we're going to say r and theta will be the outputs, and we're going to call it rect2 polar. And our inputs will be x and y. Now notice right off the bat, r, theta, x, and y are all underlined in orange. Why? Well, if we hover over it, it says this function return value might be unset. In other words, we have not declared theta or r anywhere in our function. Similarly, we have not used x or y anywhere in the function. So let's continue, and we'll start with our h1 comment. We're going to say this function converts rectangular coordinates to polar coordinates. This very first line is what MATLAB will use for the look for command. It's the immediate summary to your user if they don't know what to do. All of the comments that come after will be all the details that we want. And here you can get creative if you want. There's really no specific to it. So we can say that copy the function will calculate the polar coordinates based on known inputs of x and y. And then we can say our outputs are r, which is the radial position of the point in 2D space, and theta is equal to the angle between the point in 2D space and the x-axis. Then we can define our inputs. Horizontal position in 2D space, and our vertical position in 2D space. Keep in mind, there is no right or wrong way to put in comments. The idea is that we provide just enough information for our user to understand what this function does. So once we feel that we have enough comments and our function line is properly defined, we can now use the equations that we know to calculate r and theta. So r is equal to the square root of x squared plus y squared, and theta is equal to a tan 2d of yx. Now, we've not saved this yet, but what I'd like you to do is go to Save As, and you'll see that MATLAB will already want to save your user-defined function as whatever you listed here as your function name. So we're going to save it just like that. And now you see over in the current folder that rect2polar has been saved.